Hello, my name is Jane Cleland Huang. I'm a professor of computer science at the University of Notre Dame, and in this presentation I'm going to provide a quick overview of drone response, touching on its goals and looking behind the scenes to see how it works. We developed drone response to support rapid and smart deployment of diverse emergency response missions using autonomous, collaborating, small uncrewed aerial vehicles, which I'm going to refer to as drones throughout the remainder of this video. Our vision was for the drones to partner with humans to achieve mission success. In early phases of the project, we spent hours meeting with emergency responders to discover their needs. At the start of each mission, a human marks regions and flight paths onto a map. As drones are activated and register themselves with the ground control station, they appear on the right-hand side of the screen, and an operator then assigns them one or more tasks to perform. Our drones are all named by their unique color, and here we see that purple and green are assigned to search a region, and orange to fly along a specific route. When the operator presses the launch button, an individual mission specification is sent to each of the drones. We send it as a JSON string, and it gives the drone the instructions needed to configure itself for its intended mission. Here are some examples of very simple missions. On the left, colored in yellow, you can see the states that every drone goes through at the start of a successful mission. And then the orange placeholder represents the mission itself, followed by other blue-colored end-of-mission states. Mission-specific actions might include search and rescue, surveillance, or item delivery as shown here on the right. Other fail-safe states such as RTL and/or hover are not shown here. Some states are relatively simple, for example land, whereas others are far more complex. For example, a search state leverages an internal AI-supported computer vision pipeline to search for and detect humans or specific objects of interest. The drone response ecosystem includes multiple drones. You can see them on the right-hand side showing the onboard compute capability, including the state machine and computer vision pipeline. Over on the left-hand side, you can see the front end. This is actually a full stack system in its own right, providing various graphical user interfaces or GUIs to support human input and situational awareness, and a server for storing and retrieving data, including reusable missions. Drones, the front end, and microservices, which I'm going to mention in a minute, are all connected through an MQTT server. This is basically a message broker which forwards messages across the ecosystem. For example, when the user presses the launch button and a JSON mission specification is generated for the red drone, the MQTT server is responsible for making sure it is sent to that drone. The underlying technology used here is publish-subscribe. We show a few examples of microservices in the bottom left of the screen. One example is our airspace leaser. As drone response dispatches multiple drones at the same time, we want to ensure that they don't collide in mid-air. We accomplish this by having each drone request an air tunnel from the air leaser before each leg or portion of its flight. We guarantee that at all times when the drone is in the air, it is in uniquely leased airspace. You may have also noticed a microservice called the coordination handler. This is responsible for several different types of coordination. Drone response supports coordination between drones and between humans and drones. I'm not going to dig into this pseudocode, but the coordination handler performs several different tasks. For example, here it has logic for selecting a drone for tracking a person. And here, if the drone decides that it needs human input to determine whether a victim has been sighted, the coordination handler helps facilitate this behavior. Drone response is in fact trained specifically to detect humans from high altitudes and large distances, even when humans are occluded by other objects. These images were taken from our Nomad data collection, which includes hundreds of thousands of images taken from 100 human actors in various poses, degrees of occlusion, and distances. We use this data to train our own aerial computer vision model. Combining all of this functionality together into the drone response ecosystem has enabled us to build an innovative software platform empowering the next generation of multi-drone deployment. This overview has described the basic capabilities delivered by Drone Response MVP1. Please contact us for further information.